All right, let's dive into something pretty incredible. The system inside your brain that powers every single move you make. It's something we do without even thinking about it. But behind every action, there's this silent, super sophisticated gatekeeper making millions of decisions a second. I mean, really think about it for a second. Right now, you could stand up, you could stretch, you could wave your arms, or you could pick up that coffee mug. Your brain has to somehow select just one of those actions and pull it off perfectly while telling all the other possibilities, nope, not right now. So how on earth does it solve that huge selection problem? Well, here's the secret. It's not just about turning muscles on. It's just as much about keeping them off. Motor control is this constant, really delicate balancing act between go and absolutely not. It's a nonstop process of permission and denial, and it's all happening in milliseconds. So who's in charge of this incredible operation? Well, the structures responsible for this amazing feat are a group of nuclei deep, deep inside the brain. This is our gatekeeper, the basal ganglia. And get this, they don't command the movement themselves, but they're the ones who decide which movements get the green light. So what are they exactly? Think of the basal ganglia as the brain's quality control department for movement. Their job is really twofold. First, they have to facilitate the one specific action you want to do, and second, they have to powerfully shut down all the other competing movements that might mess things up.
Okay, so how does this gatekeeper actually make its decisions? It's really elegant, actually. It uses two opposing circuits: a go pathway that gives the thumbs up to movement, and a no-go pathway that slams the brakes on everything else.
The go pathway is so cool because of how it works. It doesn't push an accelerator. It actually removes a brake. See, your motor system is always being held in check by this internal brake called the GPI. When you decide to move, the go pathway sends a signal that literally inhibits that brake. It's a process called disinhibition. It is just like taking your foot off the brake pedal in a car, which allows the car, or in this case, the movement, to finally go forward. Now, for every single go signal, there has to be a no-go signal for all the other things you don't want to do. That's where the indirect pathway comes in. It does the exact opposite of the go pathway. Through a slightly more complicated chain reaction, it actually ends up strengthening that GPI brake, pressing it down even harder to make sure all those competing movements are shut down, no questions asked. This right here, this is the perfect yin and yang of motor control. To make just one smooth, purposeful action, your brain has to fire up the go pathway for that single movement, while at the exact same time firing up the no-go pathway for everything else. It's this beautiful, constant balance that gives us precision. So what fine-tunes this whole balance? What's the master controller? The answer is probably a neurotransmitter you've heard of: dopamine. Dopamine acts like the manager of the whole operation. It has this awesome dual effect. It hits the gas on the go pathway, and at the same time, it pumps the brakes on the no-go pathway. Both of those actions work together to tip the scales in favor of making a movement happen. So it's a beautiful system. But what happens when it breaks? When this elegant balance is lost and the gatekeeper can't manage the go and no-go signals properly, well, that's when we see some of the most profound and well-known movement disorders.
And this brings us to two really clear extremes. In Parkinson's disease, you have a loss of that crucial dopamine. This means the no-go pathway becomes way too powerful. The brake is basically stuck on, making it incredibly difficult to start any movement. On the flip side, in Huntington's disease, it's the no-go pathway itself that degenerates. The brake is broken, it can't be applied, and that leads to all these excessive, involuntary movements.
So at the end of the day, what's the big takeaway here? It's that your brain doesn't just start movements, it selects them. The basal ganglia are those silent gatekeepers constantly balancing permission and denial, with dopamine acting as the key that fine-tunes the whole system. Understanding this is absolutely fundamental to understanding how we move and what happens when that incredible ability is lost. The most amazing part is that this whole system, this entire process, operates without any conscious thought from us at all. It really is like a silent conductor, making sure our body's orchestra plays in perfect harmony. So the next time you just effortlessly pick up a cup of coffee or walk across the room, maybe take just a half second to appreciate that conductor inside your head. It's an absolute masterpiece of biological engineering, performing this incredible balancing act that makes your entire world of movement possible.